In this video, we will take a high-level view of what big data is. We live in the data age, and it's not easy to measure the total volume of the data that is being stored electronically. But as per the IDC estimates, the size of the digital universe is at 4.4 zettabytes in 2013 and is being forecasted in tenfold growth by 2020, which is like 44 zettabytes. So, where is this data coming from? So if you look around, data is coming from many different sources. And a few of the obvious examples are, look at the New York Stock Exchange, which generates about 4 to 5 terabytes of trade data every day, which is used to perform stock trading analytics and to determine the optimal trades. And similarly, Facebook hosts more than 240 billion photos, which is growing at 7 petabytes per day. It's not just photos, so you can upload videos, you have likes, Facebook messages, Facebook inbox. So all of these are generating more and more data. Similarly, ancestry.com, which is a genealogy site, which it stores around 10 petabytes of data. And you might have heard about Internet Archive, which stores around 18 to 19 petabytes of data. The LHC near Geneva, Switzerland, produces about 30 petabytes of data. And other social media websites like Twitter or LinkedIn, they generate again tons and tons of data. Similarly, devices are also generating data nowadays. So if you look at the airline, a jumbo jet can collect 10 terabytes of sensor data for every 30 minutes of flying time. Similarly, bridges and roads are fitted with uh, different sensors to monitor traffic, and these are also generating huge amounts of data. And finally, we have connected devices. So we live in the connected world, and smartphones are a great example. So for example, if when you use a navigation application like Waze or Google Maps or Apple Maps, your phone sends pings back reporting the location and the speed. So these are you are connected to the hotspots most of the time and on a data network. So just imagine hundreds of millions or even billions of devices connected to the internet and generating data every second. So how does this data look like? So you can categorize this data into three parts. It can be structured data, unstructured data, and semi-structured data. So when you say unstructured data, it's a data that is organized into entities which have a defined format. You can take documents like XML or database tables which conform to a predefined schema. Then you have semi-structured data, which is looser. Here there may not be any schema. It is often ignored, so it may be used only as a guide to the structure of the data. For example, you can look at the spreadsheet in which the structure is a grid of cells, although the cells themselves may hold any form of data. And finally, you have the unstructured data, which does not conform to any particular structure. So for example, a plain text or a data of the image. So let's move on to understand what Hadoop or HDFS is. So Hadoop is a generic software framework for distributed software of large data sets. It's also designed to support distributed processing of many concurrent tasks. Hadoop clusters are built using commodity hardwares and is also designed to handle failures automatically, which we'll discuss in detail. So Hadoop supports wide range of processing engines. Like as you can see in this image, we have MapReduce, Spark, Scala, Hive, Pig, Storm, Tej, and others. So applications can be written in a wide variety of languages. Hadoop can store data in any file format. And Hadoop also stores a range of data store technologies, including NoSQL data stores. So as we talked earlier, Hadoop is a framework for distributed storage, where large files of megabytes and petabytes are broken into smaller blocks and stored on multiple disks across various nodes or machines within a cluster. So here just understand a cluster is nothing but or a combination of one or multiple machines, which are also called as nodes within the Hadoop world. So a file that is too large to fit on one disk can be stored across lots of disks on lots of machines in a cluster. So in this example, you can see that we have 5 nodes which are part of a cluster. And if you want to store a 10 MB file or let's say 100 MB file, that can be easily distributed as per the configuration of your Hadoop. And each blocks can be stored on different disks on each of these nodes in the cluster. So Hadoop is designed for storage of large data sets, and Hadoop file system is called as HDFS or Hadoop distributed file system. And Hadoop also supports various file systems. So as you can see here, there are 10 to 11 file systems which Hadoop can support. And the obvious and the most basic one is local, which is a Unix file system of the locally connected disk. And the next one is the HDFS, which is the Hadoop distributed file system. And then we have HFTP and HSFTP, which are secure or non-secure read-only access to the HDFS. Then we have HER file system, which is a file system layered on another file system for archiving files. Then we have Cloud Store, which was formerly known as Cosmos. So there's a distributed file system like HDFS or Google Files GFS, which is written in C++. And Hadoop also supports S3 native file system and block-based file system of the Amazon Web Services. Then it supports distributed RAID. So distributed RAID requires that you run a RAID node daemon on the cluster. So this we will discuss once we start looking at the various components of the Hadoop ecosystem. Then finally we have View and Web HDFS. So View is a client-side mount table for the various Hadoop file systems, and it's commonly used to create the mount points for the federated name nodes. So we'll also understand what federated name nodes are. And finally, the Web HDFS, it's a secure read-write access to HDFS over HTTP, and it's intended to replace HFTP and HSFTP. Hadoop is also designed for distributed processing, and Hadoop's distributed compute system is called as YARN. So YARN is nothing but yet another resource negotiator. So YARN concept or the component of YARN was introduced in Hadoop 2.0. In Hadoop 1, you don't had the YARN concept. It was just the map reduce, which used to take care of the distribution, which we'll talk later. So coming back to YARN, YARN is the architectural center of Hadoop, which allows multiple data processing engines, such as interactive SQL, real-time streaming, data science, and batch processing to handle data stored in a single platform, unlocking an entirely new application or new approach to the analytics. So just remember that YARN is the foundation of the new generation of Hadoop, which is enabling organizations everywhere to realize a modern data architecture. And YARN manages the enormous processing power of all the computes or the nodes in a cluster. So YARN can handle limitless different concurrent tasks. Because jobs are executed on the nodes of the cluster, the number of jobs is only limited by the number of CPU available or the number of process available across the cluster. So where does Hadoop run on? So as you can see in this image, Hadoop runs on computer clusters such as the one which you see on the screen. So these kind of clusters can be found in the large data centers of organizations like Yahoo, Facebook, Google, Microsoft, etc. For example, Yahoo is one of the largest users of Hadoop, and Yahoo typically runs over 850,000 Hadoop jobs every day. So they have a mixture of Hadoop 1 and Hadoop 2 clusters. So let's talk about what commodity hardware is. So it is not necessary to purchase an expensive hardware to set up your Hadoop cluster. Hadoop is designed to run on commodity hardware. So commodity hardware is your desktop grade hardware, which is neither too cheap, neither too costly. So with this, scaling out can be easily achieved by adding more nodes. So when I mean by scaling out, that means when you want to scale your Hadoop cluster horizontally or add 10 nodes in the cluster or 20 nodes in the cluster, making it 50 or 100, it's very easy without disturbing your existing architecture or any processes. You can quietly add few nodes into the Hadoop ecosystem and they automatically get into the cluster and the jobs are seamlessly distributed to these new nodes. As your Hadoop jobs are running on your commodity hardware, so these commodity hardware are prone to fail. So in case of node failures, it's very easy to remove one or multiple nodes which are failed out of the cluster without impacting the currently running jobs on other nodes. So Hadoop was primarily designed to be highly fault tolerant and provide high throughput access to the applications. So Hadoop intelligently figures out nodes which are not responding to its request and can intelligently figure out where the hardware failures is, and based on that it can redirect the jobs or the various tasks to other nodes which are there in the cluster. And in case if the failed node comes back online, it's also uh, intelligent to make sure that it performs automatic recovery and also make sure that the jobs are distributed back to that system or that particular node. So many customers who are adopting Hadoop as a cheapest storage platform, they are offloading data for more expensive data warehouse systems. So instead of purchasing or maintaining high cost data warehouse systems, they are deploying low cost Hadoop infrastructure and they are able to save more data as compared to the previous months or years. So customers also report dramatic cost savings amounting to millions of dollars on this storage. So how does Hadoop solve the big data problem? Hadoop is built to run on the cluster of machines. And the other important points are Hadoop clusters can scale horizontally. So which means you can add more storage and more compute power at any point of time. So this basically eliminates the need to buy more powerful or expensive hardware. And the other interesting point is Hadoop can handle structured, unstructured, and semi-structured data. That's because Hadoop doesn't enforce a schema like your database does. So you may have a text file or a spreadsheet or an image or an audio file. You can directly push them into Hadoop and you can combine this data within your MapReduce programs or your Spark programs and finally make some meaningful data out of it once you process that. And the other important point here is Hadoop clusters, they not only provide the storage, right, but they also provide the computing power. So if you have 10 nodes in the cluster, you can store the data on each of the nodes, 10 nodes, and also you can use each of those 10 nodes for processing or executing your MapReduce jobs. The other advantage is you can store the data longer with Hadoop. So previously, because the storage costs are high and the processing capacity need required is also high, you are not able to store all the required data and probably within 10, 15 days or in 1 month, we used to just burst them out. But now with how storage has become cheaper and now you can go back and store the historical data for years together. And finally, Hadoop provides scalable analytics. So there's no point in storing all the data if you're not able to process and analyze them. So Hadoop not only provides distributed storage, but also distributed processing. And this distributed processing framework is called as MapReduce. And finally, let's look at the companies who are using Hadoop in real world. So here are some examples of Hadoop in use. The first one is Spotify, which is using Hadoop for importing social media information, for managing playlists, and also for content generation. And the current data size is more than 42 petabytes. And next one is LinkedIn, which is using Hadoop to process information for people you may know feature. which actually processes 120 billion relationships on a nightly batch process, generating 17 terabytes of data. The pharmaceutical company Merck uses Hadoop as part of their research in vaccine development. And Hadoop is also being used in one-time projects. For example, New York Stock Exchange needed to process 11 million articles from 150 years of archive data and make it available to use online. So using an Amazon cloud cluster of 100 machines, they were able to process all the articles in just 24 hours. And not only this, we have umpteen examples of other companies like Facebook, Yahoo, and Google who are using most of their services, running most of their services on the Hadoop platform. And I've provided a link below which also talks about various different companies who are using Hadoop in a big way. So that's it for today. In the next chapter, we will try to understand the block storage of HDFS. Thank you. And if you like this video, please subscribe to my channel.